I'm at Hurricane Shoals here in Banks County, and we are getting ready to start Unit 3. Unit 3 is going to take the three major types of functions, linear, exponential, and quadratic, and we're going to look deeply at the characteristics and what makes each type special and what makes them the same and what makes them different. So in this very first lesson, we're going to show you what the basic functions look like. You've already seen linear, but we're going to introduce you to the other two and show you how we can manipulate them and make them move around on the coordinate plane. Let's go ahead and get started. Unit 3, Lesson 1, Video 1. We're going to be talking about transformations of functions. So basically what this is in a nutshell is you have a function or an equation and it's plotted on the coordinate plane, and we want to know what are the different things you can do to a basic equation to move it around on the coordinate plane. What makes a difference? What transforms it? So we focus on three main types of equations. We talk about linear, which we've already talked about quite a lot. We talk about quadratic, which we haven't really talked about, but we're going to spend more time on it later. And the same with exponential. Those two we haven't spent a lot of time on, but we're going to talk more about them in this unit. In this lesson, we're going to look at the basic functions, the three easiest of these kinds of functions, and we're going to see what happens when we change them. You've seen stuff kind of like this before in middle school, but it was when we were moving like triangles around the coordinate plane. This is just going to be moving functions. So the first thing we're going to talk about is vertical shifts. This vertical means up and down. It means you're looking at the y-axis. A shift may sometimes be referred to as a translation. Basically, it boils down to if c is added to the function, where you go from an f of x to an f of x plus c, then the graph is going to shift upward by that many units. If c is subtracted from the function, then the graph will shift vertically down by c units. So here's what I mean by that. If you have this equation, x squared, and you want it to be shifted up 3 units, all you're going to do is you're going to take f of x, which is x squared, and you're going to add 3. That's it. That's all you would have to do. So this equation is the picture of what x squared looks like when you graph it. If I were going to shift that up 3 units, then each of these points would go up 3 units. So instead of being at 0, 0, it would go up to 3, 3. Instead of being at 1, 1, it would be at 1, 4. Because all I'm doing is taking each ordered pair and moving my y value up by 3. This one, instead of being at negative 1, 1, it would come up to negative 1, 4. So I get this function, which is the same picture, but it's been shifted up 3 units. If I have an equation like this that would transform this parent function down 4 units, then I'm going to subtract 4. So instead of adding, I'm going to have f of x is x squared minus 4. So when I graph that, each of these ordered pairs is going to go down 4 units. So I'm going to go down to negative 4. This 1, 1 is going to go down 1, 2, 3, 4 units. I could go on. I could come over to this one, and it's going to go down 1, 2, 3, 4 units. Same thing over here. Each of these points is going to go down 1, 2, 3, 4 units. This one would go down 1, 2, 3, 4 units. And I get this parabola, which is, by the way, the name for this U shape is parabola. And that's what it would look like. So it's very, very straightforward. Now this one is an exponential function. This is what exponential functions look like when they've been graphed. What would happen to this graph if we transformed it from 2 to the x to 2 to the x minus 1.5? Well, it would go down 1.5 points because I've got subtraction by 1.5. So each of these points would go down 1.5. This ordered pair right here would go down 1.5. I'm just looking for places where it intersects. So what I would end up having is a line that goes like 1.5. It would go like this. And it would go up. Okay, this one over here, what would happen to the graph 2 to the x if we transformed it to 2 to the x plus 3? Well, because I'm adding, this is going to be up 3 units. So same thing, I'm going to take this ordered pair and I'm going to go up 3 units. I'm going to take this ordered pair and go up 1, 2, 3 units. So this equation, or this graph then, ends up looking like this. That's all there is to vertical translations. You're just moving up and down depending on what you've added or subtracted. So you try these couple problems. This is a linear function and an exponential, and I'll see you on the other side.